Hi everyone, I wish you were doing great. In today's lesson we are going to explain the accretionary wedge part 2.
Description of a typical accretionary wedge. Southern Alaska's Chugach terrain. Southern Alaska is underlain by a complex assemblage of accreted terrains, including the Rangelia superterrane consisting of three separate terrains called the Peninsular, Rangelia, and Alexander terrains, and farther outboard, the Chugach Prince William superterrane. During much of the Mesozoic, the two superterranes formed a magmatic arc and accretionary wedge, respectively, above a circum-Pacific subduction zone. The border range's fault forms the boundary between the Rangelia and Chugach Prince William superterranes. It initiated as a subduction thrust but has been reactivated in various places as a strike slip or normal fault. On the Kenai Peninsula, the Chugach terrain contains two major units. The unit located farther inland, the McHugh complex, is composed mainly of basalt, chert, argillite, and greywacke, as well as several large ultramafic massifs. Pinhead-sized marine fossils called radiolarians from McHugh cherts throughout south-central Alaska range in age from Middle Triassic to Middle Cretaceous. The interval during which the McHugh complex formed by subduction and accretion is not well known but probably spanned most of the Jurassic and Cretaceous. The McHugh has been thrust seaward on the Eagle River Chugach Bay Fault over a relatively coherent tract of trench turbidites assigned to the Upper Cretaceous Valdez Group. After the protracted episode of subduction accretion that built the Chugach terrain, the accretionary wedge was cut by near-trench intrusive rocks, assigned to the Sanic-Baranoff Plutonic Belt, probably related to ridge subduction. The McHugh complex of south-central Alaska and its lateral equivalent, the Uyuk complex of Kodiak, are part of the Mesozoic-Cenozoic accretionary wedge of the Chugach terrain. The vast extent of the McHugh complex has proven to be of value in reconstructing the tectonics of the Pacific realm and has been compared with similar tracts such as the Franciscan complex of California and the Shimanto belt of Japan. The evolution of the McHugh and its equivalents can be broken down into three broad, somewhat overlapping phases. 1. Origin of ignous and sedimentary rocks. 2. Incorporation into the subduction complex, accretion, and attendant deformation and metamorphism, and 3. Younger deformations. Few fossil ages have been reported from the McHugh complex, but at several places on the Kenai Peninsula radiolarian chert depositionally overlays pillow basalt. Precise radiolarian age calls show that the base of the chert varies in age from Middle Triassic to Middle Cretaceous. Greywacke depositionally overlying chert has yielded early Jurassic radiolar eons. These ages are readily explained by a stratigraphic model in which the McHugh basalts were formed by seafloor spreading, the overlying cherts were deposited on the ocean floor as it was conveyed toward a trench, and the argillite and greywacke record deposition in the trench, just prior to subduction accretion. The timing of subduction accretion is not well known but probably spanned most of the Jurassic and Cretaceous. Limestones within the McHugh complex are of two categories. A limestone classed in McHugh conglomerate has yielded conodonts with a possible age range of late Mississippian to early Pennsylvanian. This clast could have been shed from the Rangelia terrain. Most of the dated limestones, however, are tectonic blocks typically occurring as severely extended strings of boudins that have yielded Permian fusselinids or conodonts. Both the fusselinids and conodonts are of shallow water, tropical, Tethyan affinity. The fusselinids are quite distinct from those of Rangelia. The limestone blocks might represent the tops of seamounts that were decapitated at the subduction zone. If so, some of the ocean floor offscrape to form the McHugh complex must have formed in the Paleozoic. The seaward part of the Chugach terrain is underlain by the Valdez Group of late Cretaceous age. On the Kenai Peninsula it includes medium and thin-bedded greywacke turbidites, black argillite, and minor pebble-to-cobble conglomerate. These strata were probably deposited in a deep-sea trench and accreted shortly thereafter. Most of the Valdez group consists of relatively coherent strata, deformed into regional scale-tight to isoclinal folds, cut by a slaty cleavage. The McHugh complex and Valdez group are juxtaposed along a thrust, which in the area of Turnagain Arm has been called the Eagle River Fault, and on the Kenai Peninsula is known as the Chugach Bay Thrust. Beneath this thrust is a melange of partially to thoroughly disrupted Valdez group turbidites. This monomict melange, which is quite distinct from the polymict melanges of the McHugh complex, can be traced for many kilometers in the footwall of the Eagle River Thrust and its along strike equivalents. In early Tertiary time, the Chugach accretionary wedge was cut by near-trench intrusive rocks forming the Sanic-Baranoff Plutonic Belt. The near-trench magmatic pulse migrated 1,370 miles 2,200 kilometers along the continental margin, from about 63 to 65 million years ago at Sanok Island in the west, to about 50 million years ago at Baranof Island in the east. The Paleogene near-trench magmatism was related to subduction of the Kula Farallon spreading center. Mesozoic and Cenozoic rocks of the accretionary wedge of south-central Alaska are cut by abundant late brittle faults. Along Turnagain Arm near Anchorage, 4 sets of late faults are present, a conjugate pair of east-northeast striking dextral and northwest striking sinistral strike-slip faults, north-northeast striking thrusts, and less abundant west-northwest striking normal faults. All 4 fault sets are characterized by quartz plus or minus calcite plus or minus chlorite fibrous accretionary wedge slickenside surfaces and appear to be approximately coeval. The thrust and strike-slip faults together resulted in subhorizontal shortening perpendicular to strike, consistent with an accretionary wedge setting. Motion on the normal faults resulted in extension of the wedge but is of uncertain tectonic significance. Some of the late brittle faults host gold quartz veins that are the same age as nearby near-trench intrusive rocks. By implication, the brittle faulting and gold mineralization are probably related to ridge subduction. Scattered fault-bounded ultramafic-mafic complexes in southern Alaska stretch 600 miles 1,000 kilometers from Kodiak Island in the south to the Chugach Mountains in the north. These generally consist of dunite plus or minus chromite, several varieties of peridotite, which grade upward into gabbronorites. These rocks are intruded by quartz diorite, tonalite, and granodiorite. Because of general field and mineralogical similarities, these bodies are generally regarded as having a similar origin and are named the Border Ranges Ultramafic-Mafic Complex BRUMC. The BRUMC includes 6 bodies on Kodiak and Afognak Islands, plus several on the Kenai Peninsula, including Red Mountain, and other smaller bodies. In the northern Chugach Mountains, the BRUMC includes the Eklutna, Wolverine, Nelchina, and Tonsina complexes, and the Klenelnichena complex in the central Chugach Mountains. Some models for the BRUMC suggest that all these bodies represent cumulates formed at the base of an intraoceanic arc sequence, and were formed at the same time as volcanic rocks now preserved on the southern edge of the Wrangelian composite terrain located in the Talkeetna Mountains. Some of the ultramafic massifs on the southern Kenai Peninsula, however, are not related to this arc, but represent deep oceanic material accreted in the trench. The ultramafic massifs on the Kenai Peninsula appear to be part of a dismembered assemblage that includes the ultramafic cumulates at the base, gabbroic basalt rocks in the center, and basalt chert packages in the upper structural slices. The ultramafic massifs may represent pieces of an oceanic plate subducted beneath the Chugach terrain, with fragments off-scraped and accreted during the subduction process. There are several possibilities as to what the oceanic plate may have been, including normal oceanic lithosphere, an oceanic plateau, or an immature arc. Alternatively, the ultramafic-mafic massifs may representative resent a forearc or suprasubduction zone ophiolite, formed seaward of the incipient Talkeetna Wrangelia arc during a period of forearc extension.